Hello everyone, this is L. Senthil, working for JCRC Jaipur as an assistant professor in electrical engineering department. Today in this video lecture, we are going to discuss about single phase induction motor. The outlines are objectives, outcomes, introduction, squirrel cage induction motor construction, working principle of single phase induction motor, and comparison between single phase and three phase induction motors. Objective and outcome. Objective: to provide fundamentals, descriptions, and working principle of single phase induction motor. Outcome: able to design and choose an induction machine for particular application. Introduction of a single phase induction motor. Single phase motors are the most familiar of all electrical motors because they are extensively used in home appliances, shop and offices, etc. It is true that single phase motors are less efficient substitute for three phase motors, but three phase power is normally not available except in large commercial and industrial establishments. Since electric power was originally generated and distributed for lighting only, millions of homes were given single phase supply. This led to the development of single phase motors. What is an induction motor? An induction motor is a commonly used AC electric motor. In an induction motor, the electric current in the rotor needed to produce torque is obtained via electromagnetic induction from the rotating magnetic field of the stator winding. The rotor of an induction motor can be a squirrel cage rotor or wound type rotor, but the rotor of a single phase induction motor can only be a squirrel cage rotor. Induction motors are referred to as asynchronous motor because they operate at a speed less than their synchronous speed. Squirrel cage induction motor construction. A squirrel cage induction motor consists of the following parts as we see in the figure: stator, rotor, fan and bearings. Stator. It consists of a single phase winding with a core and metal housing. The single phase motor stator has a laminated iron core with two windings arranged perpendicularly. One is the main and the other is the auxiliary winding or starting winding. Both windings are placed that they are parallel and electrically 90° apart. The winding is mounted on the laminated iron core to provide low reluctance path for generated flux by AC currents. Rotor. The rotor is cylindrical in shape and has slots all over its periphery. The slots are not made parallel to each other but are bit skewed, as the skewing prevents magnetic locking of stator and rotor teeth and makes the working of induction motor more smooth and quieter. The squirrel cage rotor consists of aluminum, brass or copper bars. These aluminum or copper bars are called rotor conductors and are placed in the slots on the periphery of the rotor. The rotor conductors are permanently shorted by the copper or aluminum rings called the end rings. In order to provide mechanical strength, these rotor conductors are braced to the end ring and hence form a complete closed circuit resembling like a cage and hence got its name as squirrel cage induction motor. As the bars are permanently shorted by end rings, the rotor electrical resistance is very small and it is not possible to add external resistance as the bars are permanently shorted. These options of slip ring and brushes make the construction of single phase induction motor very simple and robust. Here you can see the figure. This is the actual figure of rotor. of a single phase induction motor: aluminum ring, shaft, fan blades, and laminated iron core. This is the actual figure of single phase induction motor squirrel cage rotor. Fan used for ventilation purpose. Bearings used to reduce friction loss. It's a very important one to reduce friction loss. Here we can go for a video to understand clearly about the construction of squirrel cage induction motor. This is a squirrel cage rotor. The laminated stamping with the slots are stacked. Aluminum bar are molded in the slot. End ring. All the bars are connected together using end rings. This is the front ball bearing. Rotating shaft. This is centrifugal switch attached to the shaft. This is spring for tension. This is real ball bearing. The blue wire for two starting winding. Then now it started to rotate when we apply a AC voltage source. A rotor is inserted into the bore of a laminated stator core with the slots. Insulating sheets are inserted in the stator slots. Coils are placed in the stator slots. The stator core is covered by a stator frame or yoke with end covers. Ball bearing support. End cover, of course. And this is ventilation fan. This is terminal box where we can give supply. Working principle of single phase induction motor. When the stator of a single phase motor is fed with single phase supply, it produces alternating flux in the stator winding. The alternating current flowing through stator winding causes induced current in the rotor bars, according to Faraday's law of electromagnetic induction. This induced current in the rotor will also produce alternating flux. Even after both alternating fluxes are set up, the motor fails to start. However, if the rotor is given an initial start by external force in either direction, the motor accelerates to its final speed and keeps running with its rated speed. This behavior of a single phase motor can be explained by double field revolving theory. Why single phase induction motor is not self-start? In single phase induction motor, there is single phase supply to the stator of motor. Yeah, single phase supply can not produce a rotating magnetic field, but it produces a pulsating magnetic field which does not rotate. Due to this pulsating magnetic field, torque cannot produce, so motor is not self-start. Circuit diagram of a single phase induction motor. Here we can see this is starting winding, and this one is main winding. The capacitor is connected in series with starting winding and a normally closed centrifugal switch. Here IM is the main winding current, IST is the starting winding current. This is squirrel cage rotor. Now see this phasor diagram. The IST, the starting winding current, leads voltage by phi st, and then IM, main winding current, lags voltage by phi m. The angle between IST and IM is alpha. Now the operation. When the two stator windings are energized from a single phase supply, the main winding carries current IM while the starting winding carries current IS. Since main winding is made highly inductive while the starting winding highly resistive, the current IM and IS have a reasonable phase angle alpha. It may be 25 to 30 degree between them. Consequently, a weak revolving field approximating to that of a two-phase machine is produced, which starts the motor. When the motor reaches about 80% of synchronous speed, the centrifugal switch opens the circuit of the starting winding. The motor then operates as a single-phase induction motor and continues to accelerate till it reaches the normal speed. The normal speed of the motor is below the synchronous speed and depends upon the load on the motor. Comparison between single phase and three phase induction motor. Single phase induction motors are simply in construction, reliable and economical for small power rating as compared to three phase induction motors. The electrical power factor of single phase induction motors is low as compared to three phase induction motors. For the same size, the single phase induction motors develop about 50% of the output as that of three phase induction motors. The starting torque is also low for single phase induction motor. The efficiency of single phase induction motors is less compared to that of three phase induction motors. Simply saying, single phase induction motors are simple, robust, reliable and cheaper for small ratings. They are available up to 1 kilowatt rating. Today in this lecture we have discussed about construction, working principle and operation of single phase induction machine. From next lecture we will discuss about the types of induction machine and double field revolving theory. Thank you.